Hello, my name is Carly Parcell, and this is a video from my ma383 course that covers how I see proofs different from other math courses I have taken, and a step-by-step walkthrough via an example of how I use the proofwriting wiki in thinking through and creating a proof. I will start by talking about how going through and learning proofs is different from any other math I have done. When creating a proof, the goal is to end up with a very concise, simple, and well-written product. However, the process to get there is quite messy. In some math courses, you use definitions and coming up with a solution. In others, you sit down and look at an example of a similar question, knowing on an exam that if a number changes, you just plug in the new number into your example and voila, you get the correct answer. For proofs, there is no singular right answer. We are not just able to write a number down on the page and get full credit for the problem or homework. The wording and work that goes into creating a proof are time-consuming and tedious. No two proofs are done exactly the same, with just one number switched. There is a greater meaning behind every symbol when conducting a proof, and one small change, such as changing an and to an or sign, changes what you know, what you need to show, and likely the definitions you now need in order to produce your final proof. Proving something is difficult. Often it is much easier to find a counterexample. But there are also times when no counterexample is found, a proof is written, and then a counterexample is found later that disproves what you believe to be true. Other courses present equations and we take them as fact, but with proofs there are many steps and work that must be done to produce our final product. The problem I will now use to go through the proofwriting process with is if we let A and B be sets, determine if it is true that if the power set of A equals the power set of B, then the set A also equals the set B. I will now look at this proof using the proofwriting wiki. The proofwriting wiki consists of 7 steps. We develop examples, then create our first draft of the if-then statement. We then extract our no from our if-then statement, which are the elements that are contained between our if and then. Then we expand our no, typically using definitions of what is in our no. Then we extract our show, which is what comes after then in our if-then statement. We then expand our show, again using definitions and breaking it down to the lowest level possible. And then at the end, we create our second draft of our if-then statement. This is the first step of the proofwriting wiki, is develop examples. I will use this looking at for my problem that I stated before describing the proofwriting wiki, where if 2 power sets are equal to one another, then the 2 sets that make that power set are also equal to one another. So for this, as you can see, the power set of A is equal to the power set of B, and A has to equal B because there is no other way to create that power set other than with the given set that makes A and B for this problem. For my second example, I wanted to know what would happen if I added a 0 into the power set. This really did not change anything. I think I just looked at the null set and I was like, oh, a 0 is kind of what it looked like on the problem statement that we were given. So I thought I'd try throwing 0 in and seeing if I could create a set that did not contain 0 and a set that did contain 0 and see if it gave me 2 different power sets. But only one set could be produced with the power set that's given in this example. For my final example, I looked at adding doubles into the power set. So as you can see, there's 1, 2, 2, 2, and 1, 2, 2 there at the end. So what I noticed from this is that while there aren't duplicates, so like order, there aren't 2 separate sets that say 1, 2, 1, 2, or 2, 1. It doesn't change the the set that has to be used to make that, because there is a set of like 1, 2, 2 that's at the end, and there's also a set that's just 2 and 2 that goes into all the subsets that create that your set that is the power set for this example. So there were again only one set that could create the power set here. Moving on to step 2 of our proofwriting wiki is write down the first draft of the if-then statement. So for this problem, it is if the power set of A equals the power set of B, then the set A equals set B. For step 3 of our proofwriting wiki, which is writing down our no, we have the power set of A equals the power set of B. Moving on to step 4, which is expanding our no, I looked at the definition of a power set. So the power set is a set of all subsets of the set, like S, in this case of like the example for the definition. So then the power set of A is a set of all subsets of A, and power set of B is a set of all subsets for B, also containing the sets A and B within those power sets. For step 5, which is writing down our show, we have what comes after then, which is the set A equals set B. For expanding our show in step 6 of the proofwriting wiki, I looked at the definition of a set, which is a set A is a collection of objects, and then below that is it written not in words. And so expanding the show in this case really did not provide us very much information, but it was helpful to look at just to have in case I needed to pull it for my proof. For the final step in the proofwriting wiki is step 7, the if-then statement second draft. For this, I came up with let the power set of A equal the power set of B, and I will show that the set of A equals set B. By definition of power set, the power set of A contains the entirety of set A and all of its subsets. The same applies for the power set of B. Therefore, given the power set of A equals the power set of B, I've shown that the set A equals the set B. This is because in order to create the power set of these, the sets must be contained within the power set, which means there is no way to make two sets that are unequal given a power set that contains the set that is used to make that power set. Thank you for listening on the reasons that I think proofwriting is different than from other math courses, as well as joining me in going through how I go through all the different steps in writing a proof utilizing the proofwriting wiki. Thank you. Bye.